All right. So, a couple things before we get going. We have spring break this next week, so it makes things a little bit weird. I put up an announcement yesterday. So the CL sessions are kind of as scheduled tonight, with the exception of the one that's in the Geological Sciences building. Those sessions won't exist tonight. All right. So there's still 2 locations out of the other time slots, but the one that's in the Geological Sciences building, no one will be there. All right. So you can't attend that one. Now, because we have kind of this weird break with spring break, Module 9 CL sessions will be tonight, but then also that Monday we return, the kind of normally scheduled CL sessions for Module 9 will exist then. All right, so I think that's what, the 23rd is that Monday. So there'll be CL sessions that cover Module 9 material. That Monday we return from spring break. The Module 9 quiz is also due that Monday at the end of the day. So it's almost like I'm treating like spring break like it's not happening. All right. Now, if I had to make a suggestion, you can wait and do that quiz after spring break, but I don't want you to forget about it, right? So if you think you might forget, maybe it's good to do it sooner rather than later, but it'll technically be open over all of spring break and do that Monday we return. There's no module reading. I mentioned this last class because we won't cover new material because what's the week that we come back to spring break? That second exam. So we'll have a review class on Tuesday. The exam will be on that Thursday. My office hours will be the same that Monday. My office hours that Wednesday, I'll put up an announcement. They're going to be a little bit different. They won't be in the morning. They should instead be in the afternoon. Okay. But then TA office hours, those help sessions that Tuesday and Wednesday night before the exam are all good resources to kind of use once we get back to kind of start preparing for that second exam. So it only covers everything that we've covered since the last exam. So modules 5, 6, 7, 8, and 9. And then the only other thing is what's due by the end of the day tomorrow. That third Canvas discussion, right? So original post, tying in the data source to it, responded to other students. Okay, so these should be easy points as long as we're getting on and putting effort into that, getting it done. A good way to kind of help increase your grade or keep it high, depending on what your exam performance is. Okay. Other than that, any questions for me before we just dive into material here today? Try to get through a little bit quicker. We'll try to go through some of the easier stuff fast, and then we'll kind of focus on some of the more difficult stuff. Okay? So everything that we do will be expected for you to know on that next exam. All right, it's all the way through the end of the day today. Okay? So we talked last class about this relationship between the marginal product of labor and marginal costs, right? So we said, what is a firm trying to do? They're trying to maximize what kind of profits? Economic profits, right? As I produce more, I'm hiring less and less efficient workers. So I know that when I want to get the same increase in quantity, maybe instead of hiring 1 worker, I now have to hire 2 or 3, right? So as I produce more, yes, I'm increasing revenue. The price I'm selling the good for times quantity is going to go up, but my costs are also increasing. So what's kind of the optimal point or the optimal quantity for me to produce? So in order to be able to determine that, we need to know more about this firm's cost structure, which is what we're going to focus on today. And then we'll use this cost structure after the next exam to kind of go in more in-depth look into different types of markets. Okay. So we talked about last class, if my workers are becoming less efficient or marginal product is going up, my marginal costs or the cost per unit must be going. My workers are less effective to produce more, it's going to be more costly. And then if my marginal product, I have gains from specialization, my workers are becoming more effective. Every unit I'm producing, my marginal costs are going down. This is kind of where we left off. So we'll now start to think about some other different ways we can separate costs, which are going to be fixed and variable costs. So total cost is just the sum of these 2 different types of costs. My fixed costs are the same no matter how much I produce. So if I've got to rent the building, if I produce 10 units or 100 units, that cost is always the same. Doesn't matter on the level or the production level that I'm at, or it doesn't matter what quantity I'm producing. So in my variable costs will come from things like I'm hiring more workers, right? I'm paying for more raw materials. If I'm Chipotle, I've got to hire more workers to produce more, and I've got to buy more raw materials, more of the food product, right? So our total cost will be the sum of those 2 things. We said fixed costs are another way of thinking about what? sunk costs, right? So it doesn't matter what we do, they're always the same value. So they shouldn't really be factored into our decision making, right? We should be making decisions based off of marginal costs, right? So when we think about costs, doesn't matter how much I'm producing, that fixed cost at every quantity should be the exact same value. Now, as I start to produce more, I'm going to need more workers. I'm going to need more raw materials. So what's going to happen? My variable costs as I produce more are going to be going up, right? So my fixed costs are always the same. My variable costs are increasing. We'll kind of worry about why they're not linear here in a second. Okay? Now, how would I find my total costs? I just told you it's simply the sum of my fixed and my variables. So if I'm looking at every quantity, what would I do? Add these two values together. That shouldn't be too bad. Okay? So this is kind of our starting point. We've got total cost, fixed costs, and our variable costs. Okay? Now, in the short run, there's always going to be a difference between my total and my variable costs. Why? In the short run, some things are fixed. So what will always be true if my total cost is variable plus fixed? My total cost will always be above my variable costs, right? Because it includes the variable cost plus some other value, right? Plus the fixed costs, okay? It's nothing too crazy here yet. Now, just to revisit, how do I find the marginal anything? So if I want marginal cost, it would be the change in my total costs divided by a change in the number of units I'm producing or the quantity. Now here it's a nice easy example where the jumps in quantity are 1. So at that first unit, the change in my total cost is 70 divided by a change in quantity of 1 gives me that marginal cost of 70. And then going from 1 to 2 units, the change in my total cost is 50 divided by a change in quantity of 1 gives me 50. So on and so forth. Okay. Now, what must be true about when I'm moving from a quantity of 1 to 2? My marginal costs are going down, which must means my workers, I should be having what? My costs are going lower, my workers must be more effective, which the only way that happens is if I have gains from specialization. Past that quantity of what? Looks like 3, 4, looks like. What starts to happen to my marginal costs? They start to increase, which means my workers must be becoming less efficient or I have diminishing returns. So without the marginal product of labor, I can still tell at what quantities of production I have gains from specialization or diminishing returns. My marginal costs are decreasing, gains from specialization. If they're increasing, diminishing returns have taken over. Okay. Now here's an interesting example. What must my fixed cost be in this example? If I'm producing nothing, how many workers or raw materials have I bought? Nothing. So the only cost would be fixed costs, or like the rent on the building. Number doesn't make sense here for rent, 100. But right at a quantity of 0, all of my costs must be fixed costs. So here I would have $100 would be my fixed cost. Okay, just pointing some things out along the way. Okay. So what will our marginal costs look like visually? Initially, they'll be decreasing, gains from specialization. After a certain quantity, they start to increase because diminishing returns have taken over. We kind of connected this idea last class. This is kind of where we left off. Okay. What we're going to now talk about today, introduce this idea. I can also find average costs. Right? So what is an average? It's the total divided by the number of numbers I have, or in our case, it's going to be the quantity, right? Adding up the cost from every unit I produce, that gives me my total cost divided by quantity. Now, if instead I wanted my average fixed costs, well, my fixed cost is always the same value. So as I produce more, what am I doing? I'm taking that same $100 and I'm spreading it out over more units. So what will always be happening if my average fixed cost is my fixed cost divided by quantity? Well, if the numerator stays the same, but the denominator increases, what happens to the fraction? It becomes smaller. So my average fixed cost as I produce more is always going to be decreasing. Now I could calculate these values at every quantity. I'm simply taking my fixed cost and dividing by quantity to get my average fixed cost. I don't think this should be anything too wild, right? We're just finding an average here. It's the total divided by our quantity. The quantity represents like the number of numbers you had if you were calculating like the average of 5 numbers, right? So essentially, I already kind of understood the idea. It's like we're spreading out that same fixed cost over more units. It's always going to be decreasing. If I produce enough units, what is my average fixed cost getting really close to? 0. If I produce like 1,000,000 units in this example, my fixed 100 over 1,000,000 is essentially, I'm getting really close to 0. So what if I thought about instead my average variable costs? Well, as I produce more, my variable costs are changing, right? So how would I find the average variable cost? Simply take my total variable costs and divide it by quantity. So you'll notice what happens here is initially, as I produce more units, well, my variable costs are always doing what? They always have to go up. If I want to produce more burritos at Chipotle, even if I have the same workers, I have to buy more food, more raw materials, right? Well, as I produce more, I'm always going to see my variable costs are going up. But my average variable costs, initially, what's happening as I produce more? They're going down. At a certain point, what happens? They start to go up. This is because initially, my costs are changing by less because I have gains from specialization. Those marginal costs are decreasing. If my variable costs are what's changing, that is, marginal cost is the change in my total cost. That's factored into these variable cost values. My marginal cost for my fixed costs, they're always the same. That doesn't play a role at all. So here with our average variable cost curve, we're going to end up seeing it has kind of this U shape to it. I've plotted out these values. Initially, it's decreasing. At a certain quantity, it starts to increase. So it kind of has this U shape when we're drawing it out. Okay. Now, what if I wanted to know my average total costs? Right? Well, here, kind of show you something before we look at it, just to kind of solidify this concept. So I don't know, it doesn't really matter. You could write this out as fixed and variable. I tend to say total fixed and total variable. So I'll kind of use that abbreviation. But if my total costs are the total variable plus my total fixed, what happens if I divide both of these sides by the same thing? My equality doesn't change. What is my total cost over quantity? Average total cost. What is my total variable cost divided by quantity? Average variable. What's my total fixed cost over quantity? My average fixed. So just like total cost is the sum of my total variable and total fixed, average total cost is the sum of my average variable and my average fixed. Right? Here's the mathematical support behind why. Okay. Now, another thing I'll kind of talk about later on in the slides, but I want to kind of show you why here. So when I mention it, it's not like a completely foreign concept. If I subtract my average variable costs from both sides here, what is the difference between my average total and my average variable cost? Well, first of all, if total cost is always above my variable cost, my average total cost will always be above my average variable, right? So this difference will be a positive value. What that difference will be is always my average fixed costs. So as I produce more, what's happening to my average fixed costs? We said I'm spreading out that same cost over more units. As quantity increases, my average fixed cost is going to be going down, getting closer to 0. So what's happening to the gap in between average total and average variable? It's getting smaller. We're getting closer and closer to 0. Right? We said when we produce like 1,000,000 units, my average fixed cost is almost 0. So if I produce enough units, my average total is going to be really, really close to my average variable cost. Technically, it's always slightly above it, but that gap is getting closer and closer. Okay. Any questions on this concept before we keep moving? And I'll show you some visuals and some numbers in the slides here in a second. Okay. So if I have my average total cost, I can create these values by simply taking my total cost and dividing it by quantity. So that's how I created this additional column. Now we notice what's true about my average total cost. Well, it's influenced by my average variable cost, but it's also influenced by my average fixed. But we'll notice initially as I produce more, what's happening to my average total cost? Going down, and then eventually it starts to increase. Now here I want to make this point. Where does that kind of switch occur? Looks like it's at a quantity of 5 to 6. Initially, average total cost is decreasing. Then at like a quantity of 5, after that, it starts to increase. Now, what was true about average variable costs? It was decreasing, but it started to increase at a quantity from 4 to 5 at a slightly lower quantity, right? So they'll both have this U shape to them, but they're going to bottom out, or that minimum point of those curves will be at a slightly different quantity. In fact, the minimum point of my average total cost curve will always be at a higher quantity than my average variable cost. I'm going to start to draw them in the same graph. I'm going to point this out. It'll be a little bit more obvious. Okay? So both of them for right now, we just want to know they have kind of this U shape to them. Now, we'll focus a little bit more on average total costs right now. So if I think about, if I put all these on the same graph, we said what's happening to that gap between average total and average variable? It should be getting smaller, right? And that's because that gap, the difference is simply my average fixed costs, which are always going down. And then kind of make a similar point, where does kind of that average variable cost, what's its minimum point? Look like it's down here, where the minimum point of my average total cost is at a slightly higher quantity. Okay. So this is where we kind of start out, right? And this is just if I'm drawing this out, I've got two U-shaped curves, average total, average variable cost. Average total is always that U-shaped curve that's on top. Average fixed is always going to be just decreasing, never increases. It's not possible. Law of mathematics, same numerator dividing by a larger denominator. Okay. Now, my marginal cost, if I wanted to put on the same graph, it's going to actually hit my average total and my average variable costs at their minimum point. So this is, we'll kind of go through a reasoning behind why here in a second, but for right now, let's just take this as given. My marginal cost will always hit the average total and the average variable at their minimum point. Okay. So marginal cost kind of looks like this Nike swoosh symbol. It's not quite U-shaped. It has like a much smaller left tail than it does the right tail. Right? So it looks a little bit different. So here's all of our cost equations. We're going to use this and look at a table and think about how I could fill in different values. So my total cost is always just my total variable plus my total fixed. My averages, I just take whatever I want to find the average of, total cost, total variable cost, or total fixed cost, I divide it by the quantity I'm producing. If I wanted to find my average total, we said, using a little bit of algebra, that's just my average variable plus my average fixed. And then a reminder, we kind of used this last class. I talked about a little bit earlier. My marginal cost is the one that looks a little bit different because it's not an average, right? It's the change in my total cost divided by a change in quantity. Now, I'll introduce the idea now. We'll revisit it in later slides when we're looking at tables. What's the only part of my total cost that's changing? My variable cost. So how could I also calculate marginal cost? It's not just the change in total cost divided by the change in quantity. It should be the same as the change in my variable cost divided by a change in quantity. Either one should give me the same value. We'll see that's the case when we look at some numbers here in a second. So using these cost equations, I've got this table. And let's think about, can I fill this table out? Well, first of all, it looks a little bit daunting because there's not a lot here. So how the hell am I going to fill this whole thing out? So we'll kind of walk through this together, right? So I've got, try to leave enough room so it's kind of easy to see here. So I had what? My total variable cost, my total fixed cost, total cost. I want to make sure I'm doing this in the exact same order as the slide. This is where I should probably, I don't know, I could start doing things on a, iPad, but I'm not as good at drawing on them. So that's why I kind of rely on this dot cam, right? So I'm just going to have this table. I'm going to fill in what I was given. So I had the total cost at a quantity of 0 was 720. I had my total variable cost here was 7. I had my total cost here was 740, 15, and 202. This is just the slide. This is all I was given. Okay. So I think the easiest, I'll give you questions that look similar to this on the quiz or on the exam. Okay. The easiest column to start with is first to think about fixed costs, right? If I'm producing nothing, all of my total costs are what? Well, if I produce nothing, my total variable costs are what? 0. I can't find averages because dividing by 0, right? I have to do like in the limit, it approaches infinity. We're not going to worry about any of these averages at a quantity of 0. So all of my total costs must be fixed costs. So I can now fill in, if my fixed costs don't depend on the quantity I'm producing, my total fixed cost column should always be the same value. Now, if I know my total fixed costs and I know my quantities, how do I find my average fixed cost? Just take my fixed cost and divide it by quantity, right? Or total fixed cost if I'm abbreviating here a little bit, just saving myself some space. So what's my average fixed cost at a quantity of 1? 720 over 1 would be 720. 720 over 2, 360. 720 over 3, 240. 720 over 4, should be what, 180? Yeah, I'm checking my math here. Okay. So I can always fill out these total fixed and average fixed cost columns pretty quickly. And usually to identify what the fixed cost is, I probably want to focus on that quantity of 0 because I know the only costs that exist if I produce nothing are only fixed costs. Okay. Everybody with me on that before we keep moving? What I would then probably do is think about, okay, if I ever want to find total cost, that's total variable plus total fixed. So I'd start to look at the rows where I know 2 of these 3 things, right? So if I know my total variable and my total fixed are 720 and 7, what must my total cost be? Just the sum of those 2 things. Now here it's a little bit trickier. If I know my total cost is 727, I don't know my variable cost, but I know my fixed costs are 720. It's just a little bit of algebra here, right? What must be the difference? Oh, sorry. I already filled that one out. Where am I at? I messed up. Hold on. 740, right? So what must be the difference between total cost and total fixed cost? Just my total variable cost. So this would be what? 20 here. Okay. Now, I don't know 2 of those 3 things here, so we're going to have to do a little bit more work. Okay. So I'm now going to start to think about my averages. Well, we said my average total is also just my average variable plus my average fixed. So if I know 2 of those things, I know my average variable and my average fixed, my average total should just be the sum of those 2 things. And if I know my average total and I know my average fixed, it should just be a little bit of algebra. What must the difference between these be? My average variable costs, or 22. Okay. So I'm just using these equations to kind of fill in this information. Right. Now, here's where it gets a little bit trickier. Right. I can't use these equations anymore. Right. But what can I do? Well, I know that my average variable is just my total variable cost over quantity. So if I know my variable costs, I can always find my average variable costs. So here, what would my average variable cost be? Total variable cost over quantity, 7 over 1 is 7. 20 over 2 would be 10. I can do the same thing with my total costs. I could take 727 divided by 1, 740 divided by 2. Or what could I do here? Well, if I know my average variable, my average fixed, those should add up to my average total. So I have 727, 370. Either way I do this, I should come up with the same values, right? 727 over 1 is 727. 740 over 2 should give me 370. Okay. Now, here I've got a little bit more work to do, right? It might be a little bit trickier. So let me see. I want to make sure I can get, there we go. I don't know my total cost or my total variable cost, but I know the averages, okay? So how can I back out what the total variable cost is? Well, if I know that my average variable cost is total variable cost divided by quantity, here I know the quantity is 3. My average variable cost is 15. It's just a little bit of algebra. One equation, one unknown. I would multiply both sides by 3. And I get my total variable cost must be 45. Once again, I could do a similar thing here. If I've got now instead at a quantity of 4, why is it? There we go. Okay. So similar idea. If I know the quantity, I know the average, I can always back out the total, right? So here this must be what? 88. Well, now that I know the total variable and total fixed, how do I find my total cost? I would simply add those two together. Okay. Any questions on anything that we did here? Now, I tried just to use colors when we were kind of using like slightly different equations, but why does it increase? Right. So here I had an example where if it's only ever increasing, what must I only have had? I never had gains from specialization. Right. Now, if we have gains from specialization, initially we would see it starts to decrease and then eventually increases. Okay. But yeah, that would be the kind of concept there. Okay. Now, the only thing we haven't done is filled in any of this last column, right? So what is my marginal cost? It's just the change in my total cost over the change in quantity. This is, once I have the rest of it filled out, this should be a relatively easy step. Going from 0 to 1, what was the change in my total cost? 7. What was the change in quantity? 7 over 1 is 7. Now, this is an easier example. We'll look at some more difficult ones in a second. But my changes in quantity here are always 1. So I really just need to look at my change in the, where is it at? Here it is, total costs. Right? So here, how much are my total costs changing by? 13, 25, and then what? 35 plus 8, so 43. Now, the reason why I added this, even though this is relatively easy when I have jumps in quantity of 1, I wanted to kind of solidify this idea. I can use the change in my total cost over the change in quantity, or we said the only changes that happen in my total cost are changes in my total variable cost. So what if I use that column? Well, the changes in my total variable costs are 7, 13, 25, and 43. Right? So it doesn't matter which of those I use, I should get the same values. Questions on anything here before we keep moving? So we'll kind of look at this in the in-class quiz here in a little bit, but this would be kind of the way you would fill out a table that looked like this. And really on the exam or quiz, what this looks like is I would probably just ask you about one of these points. Okay. But we could technically, if I gave you the correct information, you could find any of them. Okay. So here's that table we started with. We just filled the whole thing out. Okay. So to the question earlier, we'll talk about why we kind of have this U shape to both our average total and our average variable costs curves. I just paper cut myself. But we said initially, because I'm spreading out that fixed cost over more units, that effect is going to be pulling down my average total cost. But part of my average total cost is not just average fixed, it's also my average variable. So even if I have examples where I have only diminishing returns, that average fixed is going to pull down my average total, while the fact that my average variable might be going up is going to be pulling it up, right? Now, initially, the average fixed cost, the fact that it's really high, is going to be influencing my average total cost by a lot, right? But as I start to produce more, hire less and less effective workers, or buy my raw materials from more and more expensive location or firms, I'm going to see that initially my average total cost is decreasing, and then I hit a certain point where it starts to increase. Now, what do average total costs represent? Another way of thinking about this, you might have heard this in other courses, or I don't know, just in life. If I'm looking at my total cost and dividing by my quantity, that essentially is giving me my per unit cost. If I'm a firm, do I want the amount of money I'm spending per unit to be high or low? Low. In fact, I want it to be as low as possible. So that quantity, where my average total cost or my per unit cost goes from decreasing to increasing, that must represent its minimum point. We'll call that the efficient scale of production. I'm at a quantity where I'm producing the lowest possible per unit costs. Okay? Any questions on this idea before we keep moving? Okay. So, what is also going to be true, and this is a very similar concept to what we talked about last class. So I'll draw this out for us. So just like we said, the marginal product of labor and the average product of labor had this relationship, the same thing will be true when I'm looking at my marginal costs and my average total costs, right? So initially, my marginal cost curve is decreasing. I've got some gains from specialization. Eventually, diminishing returns take over. And I told you earlier to just accept it, believe me for a second, that it must be hitting the average total at its minimum point. So why must that be the case, right? Well, anytime my marginal cost is less than my average total, well, if I'm adding a number, if my current average in the class is an 80, and I get a 60 on the exam, so my marginal grade is now, I'm adding to my old average a 60, it's going to pull my new average grade low, right? So if you do worse on the next exam than what your current grade is, your new current grade is going to be lower, right? So anytime marginal cost is below my average and I'm producing more units, my new average must be a little bit lower, or average total cost is decreasing. So this isn't the most technical way of remembering it, but if marginal cost is less than my average total cost must be decreasing. It's pulling it down. Now, as soon as my marginal cost starts to be above my average, what must be happening to my new average total cost? It is now being pulled up, or my average total cost starts to increase as I produce more units. So this relationship between marginal cost and average total cost, it's really the exact same as the marginal product of labor and the average product of labor. It's just that the curves are now flipped, right? Because as my workers become less efficient, my costs are going up. We have this inverse relationship. Okay. And then we kind of said that point where it hits my average total cost curve, this was our efficient scale of production. This must be the point where my average total cost is exactly equal to my marginal cost, right? My average total is no longer decreasing or increasing. It's at its lowest possible point. My per unit costs are as low as possible. That's where I want to stay, right? Lower my per unit cost as much as I can. Okay. Any questions on this concept before we keep moving? Kind of similar to what we talked about last class. We were kind of setting ourselves up to instead thinking about our workers' productivity to thinking about our firm's costs. Okay? So sufficient scale of production, right? We said past kind of either point. Initially, average total cost is decreasing. At a certain quantity, it starts to increase. The point where marginal cost hits the average total must be where it's at. Average total is at its minimum, or that efficient scale of production. My per unit costs are as low as possible. I could look at this on a table as well. So in this example, first of all, it's kind of goofy. I gave you average total cost here. I can't technically give you the average total when the quantity is 0. But if I'm producing nothing, if my total costs were 10, what must my fixed cost be? 10. Now here, my variable costs are going up, right? So if I'm thinking about my marginal costs, we said that it could be the change in my total cost divided by a change in quantity, or it could be a change in my variable costs divided by a change in quantity. Now here, the quantity numbers aren't nice and easy. They're not 1. So here, if I go from 0 to 20, what was the change in my variable costs? 5 divided by a change in quantity of 20 gives me a marginal cost of 0.25. I could then go through and do a similar thing for all of these increases in quantity. I have my marginal cost count. Now, if I know that kind of this is what's being added to my total cost, my variable cost, and my original fixed cost was 10, that's where I was coming up with these numerators. 10 plus 5, right? Then anything about 10 plus kind of adding an additional 10, et cetera, et cetera. So notice when my marginal cost is below my old average, what should happen to my new average? It should be pulling it down. Sure enough, marginal cost below my old average, my new average is lower. Produce even more. My marginal cost, it's increasing, right? So what must have taken over here? Or in fact, this case, what do I never have? If my marginal costs are always increasing, I don't have any gains from specialization. So when this marginal cost is above my old average, my new average should be a little bit lower. Now, as soon as my marginal cost is above my old average, it should be pulling my new average up. Sure enough, when my marginal cost is above the old average, my new average is higher. So let's just for a second assume I couldn't produce any quantities in between these values. What would my efficient scale of production be here? Where are my per unit costs at their lowest point? 45 units. Now, if I could produce at quantities in between these, where must my marginal cost and average total cost curve intersect? Well, if it's still decreasing here, and then it starts to increase, that switch point must be somewhere between 45 and 50. With this information, I don't know exactly where it's at, but it must be changing somewhere in that range, right? And sure enough, at this quantity, marginal cost is still below average total, and at this quantity, marginal cost is now above it. So it's somewhere in that range. So this is just kind of using some table and some numbers to kind of prove what we had visually. Okay. Oh, any questions before we keep moving here? So this is where we're going to kind of switch over and look at this in-class quiz. Okay. So I've got my in-class quiz here, and we're going to have this set to be 10:20, giving us plenty of time. I'm going to publish it. We're then going to think about, I think the number is 78.03. Let's see if I'm doing this from memory correctly. So 78.03 should get you into that quiz. Is that working? Yes? Okay, I did it from memory right. So 78.03 gets you into that quiz. We'll then kind of walk through these together. Okay. So the first thing, hopefully this one's relatively easy. Okay. If I were to ask you this would be like a gimme question on the quiz or the exam. If I am asking you for the total variable cost of the 20th unit, I know all of my average variable costs and I know my quantities. What should I be able to do? Well, my average variable cost is my total variable cost divided by quantity, right? So hopefully you have that pulled open in front of you. My average variable cost or my total variable cost divided by quantity. I could use any quantity I wanted to. So even though, or actually, no, I can't. It's asking me specifically about the 20th unit, right? So I know at a quantity of 20, my average variable cost is what? 25. So it's just a little bit of algebra to solve for the one thing I don't know. Multiply both sides by 20. 20 times 25 should give me that total variable cost of 500. Right? So anytime I know an average and a quantity, I can always back out the total. Doesn't matter if it's a total variable, total fixed, or a total cost. Now, the second any questions on that one before we keep moving? Okay. Now, the second question is a little bit trickier because I'm asking you for the marginal cost of I'm asking you for the total cost of 60 units. The tricky one is the next one. So total fixed cost, here's where if I know my average fixed, that should always be my total fixed over quantity. I could use any point in that table, any quantity, and I should get the same value. So if I look at a quantity of 10, it tells me my average fixed costs are 10. A little bit of algebra. 10 times 10 should give me total fixed costs of 100. So there we should have the two answers already, right? I don't expect you to submit anything for the third. So you just need to answer the first two questions for this quiz and hit submit. Okay? So we already found the answer to the first question. We now have the answer to the second. So I had it set to be due at 10:20. It gives you still 3 to 4 minutes to make sure you're getting this submitted. I'm going to kind of continue to work through this, showing you how you would solve 3, but you don't need to answer question 3 to get the full points for today. Okay. Now, I just want to make an additional point here. Is that clear what I'm saying? So make sure you're hitting submit now. We already have the answers to the first two questions. That's all you need to get full points. But what I could have done in question 2, we already know the value. But let's say instead, I use that same equation and I looked at a quantity of 50, right? So at a quantity of 50, the table told me my average fixed costs were 2. Hopefully, if I solve for total fixed costs, well, they should always be the same. Doesn't matter how much I produce. So if I do a little bit of algebra here, sure enough, I get that same total fixed cost value of 100. Okay. Now, the third question is going to be a little bit trickier, and this is why I didn't ask you to answer it, right? I wasn't sure if we would work through this together based off of the number of people that are gone. Sometimes I feel friendlier if there's more people that aren't here, okay? So the third question is actually asking us for the marginal cost of the 40th unit. So I'm going from a quantity of 30 to 40 here. I don't know my marginal costs, but I know my average variable costs that these are 23.33 repeated and 25. Okay. So when we said I'm looking for the change, or sorry, my marginal cost, that was the change in either my total cost over the change in quantity or the change in my total variable cost divided by the change in quantity. Okay. So if I know my variable cost, what can I always find? Well, my average variable is my total variable over quantity. Okay. So in fact, I think we have here, we already found the total variable cost at a quantity of 40 in our earlier one. So that was, or no, we didn't. Sorry, we didn't find that. So how am I going to find that? Well, if I know the average is 25, I know the quantity is 40. It's just a little bit of algebra to find my total variable cost here would be what? 1,000? Am I doing math in my head correct there? How would I find the total variable cost here? Well, now I've got at a quantity of 30, average variable cost is 23.33 repeated. if I do this algebra, what, 30 times 23.33 repeated, I think I get 800 here. Does anybody want to check my math? Is it 7? Oh, what did I do wrong here? Sorry. It is 700. All right, so we've got 700. Okay. If I want my marginal cost, what is the change in my total variable costs here? Well, 1,000 minus 700 is 30. What was the change in my quantity? 10. So here, what do I have? It's not 30. Someone call me out here if I'm doing really bad math. 1,000 minus 70 is what? 300. 300 divided by 10 gives me that marginal cost of 30. Okay? So sometimes if I don't have the totals, I have to back that out from knowing the averages. But once I have either the total cost or the total variable cost, I can then calculate my marginal cost because it's just the change in that total or total variable cost divided by the change in quantity. The changes in quantity won't always be 1. In this example, the changes in quantity were 10. Okay? So you could solve that third question. Didn't expect you to kind of submitting this quiz here today. Okay? Any questions before we keep moving here? All right. So kind of got that out of the way. So we'll kind of come back here. And we'll now start making a differentiation. Everything we've done up to this point, well, I had fixed costs in every example, so I must have been in the what? Short run. In the short run, we said we can't move to a new building. We can't relocate overseas. So some things were fixed, or we were going to have some fixed costs. So there was always a difference between our average total and average variable because in the short run, we had some fixed costs. Okay? Now, the same idea we talked about, that marginal cost is average total at its minimum point, the same idea would apply to average variable, right? If marginal cost is below the average variable, my new average variable cost must be decreasing. As soon as marginal cost is above average variable, my average variable costs are increasing. Okay? And given that there's always this difference between average variable and average total, those quantities where marginal cost hits my average variable and average total will always be different. In fact, because my total costs include additional costs, which are the fixed costs, it'll always hit my average variable. Oh, sorry, what will hit it? Marginal cost will always hit average variable at a quantity that is lower than where it hits my average total. So this will always be the short run cost structure that a firm faces. We'll be drawing this out a lot after the next exam because we're going to be looking at different types of markets. Regardless of the market, every firm faces a similar cost structure. We have these maybe initially decreasing marginal costs because of gains from specialization. Eventually, those marginal costs start to increase because of diminishing returns. And that gives us kind of these U-shaped average total, average variable costs, where there is a difference in between the two in the short run, but that gap is getting what? Smaller because our average fixed costs are getting closer and closer to 0 as we produce more. So if we move away from the short to the long run, I had basically copy and paste this slide from last class. In the long run, we can change everything. I can move to a larger production facility. I can move overseas, right? Maybe I get out of, if I'm a sports team, I'm getting out of like big contracts, right? I can kind of trade players, things like that. So the idea in the long run is I can change everything. If I can change everything, my fixed costs go to 0. If my fixed costs are 0, what's true about my average total and my average variable costs? They would be the exact same thing, right? So if I'm thinking about the long run, average total and average variable costs are the exact same value, which means marginal costs will hit them both at the same point, right? At that minimum point. Now, what I'm going to go through next is maybe not as important for the quiz or the exam, but I want to give you some support as to why the long run average total cost curve looks like what it does. And we'll use those concepts in future, in future modules. So the slides are nice here, right? because I can use these animations. If I have three different production facilities I can choose from, small, medium, large. At any quantity below QA, what's the lowest possible average total cost? Which of these three curves would I be on? So if I'm looking at this quantity, what's my average total cost in the small production facility? It's going to be less than if I move to a medium-sized production facility. And you can't even see it here, but it's going to definitely be less than the large one, right? The average total cost of the large production facility is way up here. Yeah. So any quantity below this point, the lowest per unit cost I could be at is on this small production facility. Now, as I want to start increasing my quantity or output, eventually there becomes a point where if I wanted to produce past QA, if I stay in this small production facility, it's not going to be as efficient. My per unit costs start to increase a lot. Well, in the long run, if I can change every factor of production, I can move to a larger production facility. If I keep producing more and I switch over to a medium-sized production facility, I now have lower per unit costs than if I stayed in that old building. So past QA, what size facility do I want to be at? Or where are my average total costs the lowest? In the medium-sized production facility, right? So past QA, the lowest possible per unit costs I can be at are in this medium-sized production facility. Now, if I wanted to continue to increase my quantity past QB, now if I stay in that medium-sized production facility, my per unit costs are greater than if I move to this large production facility. So past QB in the long run, if I can change what production facility I'm choosing, now I'm going to want to switch over and move to a larger production facility. Right? So if we can change these fixed factors of production, we always want to be switching to a larger and larger production facility if it provides a lower per unit cost, or the average total cost in that production facility is lower than any other size we could choose. Okay. Now, if I think about where would my long run average total cost curve be? Well, these really represent three short run average total cost curve. If I'm in the small production facility, the blue line is my short run cost curve, average total cost curve. If I'm in the green production facility, I can't change from that in the short run. That would be my short run average total cost curve. If I'm in the long run, right, or sorry, in the long run, if I'm in the large production facility and I can't change that currently, that would be my short run average total cost. But because in the long run I can choose which production facility I'm in, essentially my long run average total cost curve just becomes the lowest of all of those possible short run average total cost curves I could choose from. So because I can change this fixed factor of production in the long run, I'm always going to be moving to different production facilities that provide me the lowest possible average total cost. So this kind of red line here would really represent our long run average total cost curve. It's just the minimum of all of those short run average total cost curves. Now, in practice, I don't only have three production facilities I can choose from, right? I could choose from a bunch of different production facility sizes. So here I've got, I can't even tell, 12 or so different short run average total cost curves. My long run average total cost curve would be the lowest of those short run total cost curves that I could be on, or look something like this. Okay. So this is where so what's the shape of this long run average total cost curve? It still kind of has this U shape to it. Okay. So if I'm thinking about the different ranges I have for my long run average total cost curve, and this is where I might ask you something about this on the exam. I won't expect you to kind of answer questions necessarily that look similar to this concept. But once I have that long run average total cost curve, we have three ranges. If I'm increasing my production, I'm changing this fixed factor so that I'm lowering my per unit costs. Well, if I'm lowering my per unit costs, is that a good or a bad thing? Good. So we're going to say we have economies of scale. I'm scaling up production. things are getting better. I'm lowering my per unit costs. Now, I drew this kind of large. In practice, it's probably going to be a bit much smaller portion of my long run average total cost curve. But if I'm scaling up production and my per unit costs remain the same, we would say that by scaling up production, I have constant returns to scale. My per unit costs aren't changing at all. And then eventually, as I scale up production, my average total costs start to increase, which for the firm is a bad thing. We'll call this diseconomies of scale, right? My per unit costs are getting higher. So based off what is happening to my average total costs, I know what portion of that average long run average total cost curve I'm on. If by producing more, my average total cost is increasing, I've got diseconomies of scale. If by producing more, my average total cost is staying the same, constant returns to scale. If by producing more, my average total costs are decreasing, I've got economies of scale, because that's a good thing for me as the firm. Okay. So these are kind of our three different ranges of that long run average total cost curve. Okay. This would be something I could ask you, or I might ask you questions on in the quiz or the exam. This stuff was more of like support why that long run average total cost curve looks like what it's on, looks like what it is. Okay. Any questions on this idea before we keep moving here? Okay. Now, this is things that I definitely will ask you on the exam. Okay? And the quiz. Well, sorry, not quite there yet. But once we start to talk about concentration of markets, I will ask you questions about this. So we're going to focus basically after the next exam, we're going to focus on this. For right now, we don't need to know the differences between these types of markets. We just know that there is going to be different types of markets. So perfectly competitive markets versus monopolies. You've probably heard of this idea of monopoly. You've played the game. A monopoly is a market where there is only one firm. We would say that's the most concentrated market. One firm has all of the market share. Okay? Now, if I'm thinking about how do I measure market concentration, we're going to have two different measures of this. So the first one is relatively easy. It's called the four-firm concentration ratio. All we do is take the market share of the top four firms and add them up, right? So if I have a monopoly, what percent of the market do they have? 100%. So the four-firm market concentration, well, there's only one firm. So if I add up the top four firms, I'd have a four-firm market concentration ratio of 100%. Now, what if I have two firms evenly splitting market share? I'd have 50% and 50%. What would my four-firm concentration ratio be? Add up the top four firms, it's still 100%. So it's an okay measure, but it doesn't allow me to make any differentiation between really concentrated markets. Based off the four-firm concentration ratio, I couldn't tell you if a monopoly existed. I couldn't tell you if there was 2, 3, or 4 firms. Because if there's 4 firms or fewer, the four-firm concentration ratio will always be 100%. Now, it still does allow me to identify different market concentration if there's more than 4 firms. So you can give an example. If I had 100 firms and each one had 1% of the overall market share, what would my four-firm concentration ratio be? Top 4 firms, each have 1%, add them up, 4%. So the closer it gets to 0, the less concentrated the market is, right? The more spread out market share is amongst all the firms in that industry. Now, we said it's not a great measure, right? But if I wanted to do this, if I just had sales values, how could I find my market share as a percent? Well, if this firm A is selling about $22,000, to find my market share, I would need to divide that by the total sales in that market, which I could kind of find by adding up all these values. If I do it this way, though, that's not my market share as a percent. That would be my proportion. So I would then need to do what? Multiply that by, how do I move from proportions to percentages? I multiply by 100. Right? So to find firm A's market share, I would take 22,000, divide it by whatever the sum of every firm's sales are, and then multiply it by 100, right? I would do that for every single firm and then add up that market share of the top 4 firms. Now, so I could also think about is I take the sales of the top 4 firms, divide it by the total sales in that market. That represents a proportion. I would then multiply that by 100 to get the percent. Okay. So this market has a 4 firm concentration ratio of about 41% or 42%. Oligopoly models, usually we think of those as like smaller numbers of firms. So really with this 4 firm concentration ratio, close to 100%, right? We would actually not be super concerned about this market, right? There's no hard and fast cutoff, right? But for sure, anything of 100% is going to be a really concentrated market. There's going to be a small number of firms. Now, like 90% is still pretty high. In fact, if I had an example that looked like this, this is slightly old data, but this is still pretty accurate. If I look at cell phones and operating systems, there's really only a couple major players. So if I look at this 4 firm concentration ratio, I could take the top 4 firms, add up their market share, and that would give me the 4 firm concentration ratio. Now, let's say I left out these values. If you know there are 4 firms, and then every other firm has 0.1% of the market, what would the 4 firm concentration ratio be? Well, total market share will always be 100%. If you know other than the top 4 firms, every other firm only has 0.1%, the market share of the top 4 must be 99.9. But this is a market we would definitely be concerned about, right? This is, the top. In fact, we'll talk about a better measure other than just the 4 firm concentration ratio that would really identify this market as a problem, right? So that next measure we have, right, is going to be called the HHI. So before I get there, just to kind of discuss a little further, these are all pretty heavily concentrated markets, right? The automobile industry, if you actually look at like the top 4 manufacturers, I don't know what they are without looking them up. My guess is it's like Toyota, Honda, Chevy, and Ford. I would assume those are the top 4 firms. We've got a 4 firm concentration rate of about 80%. 80% of the market is concentrated with just those 4 firms. Now, video game consoles, there's only a handful, right? So they have 100%, right? Weirdly enough, I don't know what the companies are, but the tennis ball market, apparently there's not many firms making tennis balls. And so there also has a 4 firm concentration ratio of 100%. So we could do this for all kinds of markets. These are just some that are heavily concentrated based off the data that exists out there. The problem is, if we have 1, 2, or 3, or 4 firms, that 4 firm market concentration ratio will always be 100%. So we have a better measure, which is called the Herfinau-Hirschman Index, or the HHI. Okay? So what that does, excuse me, is it takes the market share as a percent of every single firm, squares it, and then adds it up, not for the top 4 firms, for every single firm in that market. So if I had a monopolist, what would the market share for that monopolist be? They're the only firm, so their market share would be 100%. 100 squared would be 10,000. That's the highest possible HHI we could ever see. Now, if I had a 2 firm market, both evenly splitting market share at 50%, what would my HHI be? 50 squared plus 50 squared, which if you put that in your calculator, gives you a value of 5,000. So as that HHI becomes lower, I have less of a concentrated market. I can identify the difference between a market where there's only 1 firm and a market where there's 2. In fact, technically, what if I had the 2 firms, but it's 99% and 1%? Well, if I do the calculation, I'll still end up with an HHI that's slightly below 10,000. So I can make a much more clean, I can differentiate any market, right? So it's a much better measure, okay? So just to go through some examples, we could go through it here, but I'll kind of show you in Excel how to make some quick calculations. I also threw in at the end, I don't know, just some different pie charts. When you think about like beer producers, there's like two major players. We could look at the four firm concentration ratio, HHI of that market. Auto manufacturers, we can see if I guessed right. Looks like, now this is some old data, but yeah, I mean, we could look at the top four firms. We could calculate the HHI. So I'm going to update that Excel file I gave you. Here's just another example of firms' cost structures. I'll probably revisit this, or I might use this when we do some review on Tuesday, just for a review of these concepts. I mean, we can go through the specific questions that people have. In fact, what I think I'm going to do is I think I'll have some time either today or tomorrow. I put up another video, just if you're interested in how to do this in Excel. I might record a small video, just if you're interested. We've already covered all the material that I was going to work through. I just wanted to show, like, instead of doing all the math by hand, you can do this in Excel as well. Now, I'm also going to use Excel right now just to do some really quick calculations for us and kind of show how these different market concentration ratios are kind of helpful, okay? So how would I find the four firm concentration ratio? And I'll post this Excel with this sheet after class today if you want to go back and review. So I've got 6 different types of markets, and I'll add a 8th one at the end. Right? So if I want the four firm concentration ratio, that's always going to be adding up the market share of the top 4 firms. Okay? I could copy this down. It's going to update my cell references. So it's kind of looking at every scenario, what that 4 firm. Now, every time I only have 4 firms, my 4 firm concentration ratio is 100%. Now, as soon as I have a 5th firm, it starts to become lower, so it's somewhat of a useful measure. But for these first 5 scenarios, I can't tell if these markets are any more or less concentrated than another. Where I know that some of them are, because in one of them there's 1 firm, in some of the others there are 4 firms. Okay? So the HHI is going to allow for me to make differentiations between these kind of different markets. So how did we find the HHI? I took each firm's market share and I squared it. Now, I'm going to go through, even though we don't have values here, when I copy this down, this will kind of do all the math for us. If there's nothing in the cell, it's not going to square anything, so nothing's going to get added. But kind of this formula would calculate the HHI for each additional kind of scenario we're looking at, right? So here, I'm just squaring up the market share of every firm, and I'm having Excel do this quickly so I don't have to enter this all in my calculator. So what should we set the HHI of a monopolist be? Well, the market share is 100%. 100 squared should be 10,000. It's the highest possible HHI we could ever see. Now, when I go down to this market that has 2 firms evenly splitting the market, we said we get an HHI of 5,000. Now, if I have a market where one firm has 80%, the other firm has 20, I mean, just intuitively, if I compare that to the 50-50 split, is that a more or less concentrated market? More of the market share is concentrated with one of those firms. Our HHI should be larger. Sure enough, if we go ahead and calculate it, 80 squared plus 20 squared gives us this higher HHI. Okay. And then what if I want to do this for the 4th scenario? Well, now I, instead of having 2 firms, I have 4 firms evenly splitting the market share. So what should be true about the HHI? It should be even lower than before. 25 squared plus 25 squared, etc., gives me this HHI of now 2,500. Sure enough, it is lower. So in all these scenarios, the 4 firm concentration ratio is useless, right? I couldn't identify any differences in these markets. But the HHI allows me to identify some differences. Okay? And in fact, even if I have 4 firms, but in my 5th scenario, one of the firms has 70%, my HHI, is this a more or less concentrated market? Well, instead of 4 firms evenly splitting it, I have 1 firm with 70 and the other 3 only have 10 each. It should be a more concentrated market or have a higher HHI. Sure enough, it does, right? And in fact, what's interesting here, even though I have more firms, between scenario 2 and 5, which one is a more concentrated market? based off the HHI, what's the most concentrated a market could be? Only one firm has all of market share. So the higher the HHI, the more concentrated. Even though I have more firms in scenario 5 than I do in scenario 2, because in scenario 2, at least they were evenly splitting the market. Here I have one firm with a lot of the market share. My HHI is higher. In fact, that's telling me that even though there's more firms, this is a more concentrated market. To your point earlier, I should be more concerned about this market, even though there's more firms being oligopoly as opposed to one that had 2 evenly splitting. Now, I wouldn't ask a question like that, but since you asked it, like I'm relating it to kind of just thinking about higher HHIs mean more concentrated markets. And then I could do something like this just to make the point. If we have 5 firms, right, calculating the HHI, I just have more firms' market shares to square now. That's just a little bit more work to do in my calculator. Now, the scenario I don't have added in here, but to think about, what if I had like 1,000 different firms? Well, every single firm is going to have 1%, right? Oh, what did I do here? I must have actually accidentally. This should be E, right? All right. So the top 4 firms have 4% if they're all evenly splitting it. But if I have 100 firms and they all have 1% of the market share, 1 squared is 1. But I would have to do that 100 times. So if I had a market with 100 firms, each have 1% of the overall market share, what would my HHI be? Well, 1 squared 1,000 times, or sorry, 100 times would be 100. All right. So as I get a less concentrated market, 100 firms each with 1% market share, that's a pretty good market. It's pretty, a lot of competition. My HHI gets closer and closer to 0. Now, the only way it would ever technically be 0 is if I had an infinite number of firms evenly sharing the market, which can't happen, right? But 1 over infinity would be in the limit here. So we don't ever actually practice see an HHI of 0, but the less concentrated the market gets, or the more competition we have, it gets closer and closer. So I'll post the Excel file with this added sheet in it after class. I'll get up a video either today or probably more likely tomorrow, where I kind of walk through this Excel example. And this isn't going to, you don't have to use Excel in the exam. So this is just more for those of you who are interested. But otherwise, Canvas discussion due at the end of the day tomorrow. That module 9 quiz due that Monday after we get back from spring break. I will probably not keep a close eye on my email over spring break. But if you do send me an email, I'll try to respond within 24 hours. Otherwise, have a fun, safe spring break. And I hope we'll see all of you back Tuesday.